Hello, I welcome you all in this lab class related with the subject surface engineering. And in this lab class, I'll be talking about the adhesive wear test. You know that the performance characterization of the modified surfaces is extremely important to determine if the modified surface is suitable for the given purpose, or to see like how long a component's modified surface will perform under the actual tribological conditions. So to assess that, we need to perform the different kind of the tribological tests. So apart from the slurry erosion or the abrasive test or the adhesive wear test is another one. So the most common adhesive wear test is done using the pin on disc machine. So here we have one disc and over which the sample to be tested is kept under pressure, and the disc is rotated. So there is a direct metal to metal contact between the pin which is to be tested and the counter surface, which is again of the steel. Most of the time it is hardened steel plate, and then the disc is rotated at a constant speed. The speed we can identify that will depend upon the kind of the speed at which we want to conduct the adhesive wear test. It can be 0.2 meter per second, it can be 2 meter per second, depending upon the purpose and application of the adhesive wear test. So what we do basically, if we see this is one of the pin on disc adhesive wear testing machine, which is well supported with the required instrumentation. Like when the pin is rubbing, the counter surface frictional heat will be generated. So we may be interested to measure the temperature of the pin during the test. When the counter surface and the pin are having the relative motion against each other, then the frictional force will be generated. The friction force will, different magnitude of the friction force will be generated when the sample is rubbing the counter surface at different load, different speeds. So by changing the parameters, we can also see what is the kind of change in temperature of the surface of the pin which is being tested, or what is the change of the what is the kind of change which is in friction behavior which is taking place. And these parameters are basically acquired. These the parameters are acquired, and we can see here, this is one of the you can say software with the machine itself, wherein we can see the kind of the wear in terms of the loss of the dimensions basically in micrometer which is taking place. Then there is a friction force. It also measures and shows the variation in friction force as a function of the displacement or as a function of the time. Then there is also a window for showing the temperature as a function of the time during the test. Okay, so the friction, temperature, and the wear loss which is happening, all those can be acquired and can be seen in the real time basis. So we have an option to change the normal load at which the pin is rubbing the counter surface. So for that we use the different dead weights, those are applied. So normal load is applied through the lever arrangement here, I'll be explaining. And the friction force is measured using the suitable sensors fitted with the machine, and LVDT kind of the displacement measurement system is used. LVDT kind of the this transducer is used for measuring the wear loss in terms of the micrometer. I believe this system is having the maximum wear depth measurement of the 2 mm, so that is 2000 micrometer. So if we see, if we are interested to conduct the adhesive wear test in control environment, then what we can do, this is just a cover one. So we can we can make it a closed chamber, and then we can supply the suitable environmental gas, which may be oxygen, carbon dioxide, hydrogen, or the nitrogen, or it can be done or we can feed the lubricant also, if you want to see that what is the kind of the friction and wear behavior of a given material against the given counter surface. So this is one of the simplest thing. So what we do, this is the disc basically against which the pin or the sample which is to be tested is rubbed. So what we do, this is the sample holder. We hold the sample or the pin in this sample holder, and then normal load is applied through this lever arrangement. So here there is a you can say the chain pulley arrangement or the wire pulley arrangement. So the dead weight is applied from the back side. So whatever the load is being applied, it is directly load is applied, say 1 kg, then 1 kg normal load will be acting onto the sample. So if you want to conduct the adhesive wear test at a higher load, then accordingly we try to change the magnitude of the dead weight that is being applied. So we see then another parameter is the sliding speed. So by changing the rotational speed of the disc, we try to achieve the desired rotational speed, and depending upon the distance of the sample where it is rubbing the counter surface, that will be determining the sliding speed, because we use the simple pi d n. N is the revolution per minute, and d is the diameter of the wear track over which the pin is rubbing the counter surface. Okay, so from the pi d n relationship, we can determine the sliding speed per minute. So if we change the revolution per minute, we can directly change the sliding speed. Alternatively, we can also get the minor adjustment in the sliding speed by changing the diameter of the wear track. Okay, so now we will be showing. So there is another very good use of this kind of setup here. We can change the steel disc with the emery paper, also with the abrasive medium, if we are interested to perform the abrasive test. But this is not the standard way of performing the abrasive test. Most of the time, pin on disc is particularly used for performing the adhesive wear test, where one metallic pin is rubbed against the another hardened metallic surface, which is most of the time hardened steel only. So now we'll demonstrate the adhesive wear test, how it is performed. Okay.